All right, Friday. Everyone's gone home 3 hours ago. Well, 1 hour ago, 1.5 hours ago. But I'm still here for you, so that you ace the test. Let's finish it off. So 22, we have x equals 3, which is a cross through. X equals -1, which is a cross through. -1. And x equals 5, which is a bounce. Because when it's an even power, we bounce. Even power, we bounce. So that's x to the third times x to the first times x to the fourth power. So that's 3 plus 1 is 4. 4 and 4 is 8. So we have a plus x to the 8th power, which the end behavior is going to be up. There we go. That's equal to, it's equal to, so we do close holes, equal to close holes. So that's going to be -1, 3 and 5, all close holes. Right, all closed holes. So then, it's going to be the end behavior is up. And we're going to cross through at -1. Go through the y-intercept. Cross through at 3, but then bounce at 5. Wayoo! So what is our interval notation then? Well, our interval notation depends on the inequality. So it says less than or equal to 0. So less than 0 is below the x-axis. So that's going to be from -1, from -1 to 3. So from -1 to 3. In union with, that's above, right? That's above, that's above, that's above. That's the only one below. Oh, but actually because of the equal to, it's actually, you have to include the 5. So in union with 5. Okay, next one says to use your calculator and get the answer just using your calculator. We have one of those on the test. So we go to y equals, and we type in x to the fourth power plus 3x to the third power minus x squared minus 7x minus 4. And so we go ahead and graph that guy. There we go. Okay, so we want less than 0, and we want open holes. Right? So less than 0 open holes. So less than 0 is going to be all the numbers that are below the x-axis, less than 0. Was that a less than 0? Yeah, just making sure, Okay, using our calculator. So approximately we have a 0 there at -2.57. So we got -2.57, good. And then we also have another 0 right at 1, it looks like. There we go. You know, you can actually do something to tell for exactly what it is. It's called the 0 function. 0 program. So you go second calc, you go 0, you go enter, left bound, enter, right bound, enter, you're going to guess right about there. So it's actually -2.56. We were really close enough. And then the next one will be at -1. And then the other one will be at, where's that one about? Between 1 and 2, it looks like. We might have to use our 0 feature there. Let's take a look. That's our guess. So second calc, 0 feature. So left bound enter, right bound enter. We're going to guess right about there. So 1.56. And so with our graph, there's our graph. Remember, it's open hole because it's less than. So we go down. At 1, at -1, we bounce. We bounce. And then cross through. Okay, so we want everything below. So we'd say our interval notation is negative 2.56 to negative 1. We can't include negative 1 because it's an open hole, can't include it. So in union with negative 1 to 1.56. Wayo! Okay, last page. So convert it to standard form, and then put in your calculator. See how fast we can do it. So that's 14x to the third power plus 7x squared minus 21x minus 3 times 2, negative 6x squared. Pause me, try it on your own. Pause me. Try it on your own. Pause me. Okay, so we got our standard form first. Standard form is 14x cubed. 7 minus 6 is 1x squared minus 24x plus 9. So there's our standard form. So if you grab both of them, you can tell if you actually did the standard form right on the test. So we go parentheses 7x minus 3 times 2x squared, right arrow, plus x minus 3. Wayo. So there's that one to get the maximum minimum. Let's see if we graphed it right. If we graphed it right, it should match up exactly. So 14x cubed, right arrow, plus 7x squared minus 21x. Oh, forgot the plus 9. There's the plus 9 minus 20. Oh, 24x. Newbold, Newbold, you're looking at the wrong thing. Sorry. So that's actually a plus 1x squared. It's okay to make mistakes as long as you catch yourself and fix them. So 24 minus 24x plus 9. Okay, let's graph it. Yeah, it's identical. Same function, same function. We're going to have to change our window to 20 or maybe 30 because it's out of the window there. There it is. So trace. Where's the maximum feature? How do you do maximum? Second calc. Second calc, maximum, option 4. So we go left bound, enter, right bound, enter, and then we're going to guess right about there. So our maximum is negative 0.780. Negative 0.780, comma, 21.685, rounded to the nearest 3 decimals. 21.6846, and that rounds it up to a 21.685. So there's our relative maximum. There's our relative maximum. Then we go back to y equals and graph, trace. Remember, hit the trace button, go down to the minimum. So second calc minimum is option 3. Left bound. Right bound. Enter. Guess right about there. So we get 0.732. So 0.732, good. And then negative 2.541. Negative 2.541. So that's how you do relative maximum minimum. Ace it on the test. Okay, determine whether the function is odd, even, or no symmetry. So basically it has to be symmetric to be even or odd. It has to be symmetric. And so for it to be odd, right, you have to rotate it about the origin. Like that. And it does match up. I just messed up a little there. Okay, so as long as you can rotate it, it's the same thing back, then it's going to be odd. Explain. Because the graph is symmetric about the origin. And then this one is symmetric, right? So this one is symmetric. You can fold it like a book, and the graph is there matching up with it, right? They're both there like a book that you can put together. And so if you go ahead and if we go ahead and just flip that over, left and right, flip it. See, look, it matches up. And so as long as it's got the symmetry there, right? So it's going to be even. Even since it's symmetric about the y-axis. Okay, and so if it's neither, that means it's not symmetric, right? Nope, there is no line there. There's no line there, so it's not symmetric there. If you try to rotate it about the origin, you try to rotate that. So that's going to end up somewhere else, and it's not going to match up again. It's going to be like higher up. So it's not quite symmetric around the origin. So this point here, if you rotate it 180 degrees, at negative 1, 1 will actually be here. And so then that lump will actually be going this way, like that. Yeah, so that's not symmetric. So no, it's neither. And it's because no symmetry. No symmetry for the y-axis or the origin. Then you're going to do it on the test. You're actually going to do it visually using your calculator. And so you're going to go ahead and go to y equals. We're going to clear our graphs. And you're going to type in a negative absolute value. Don't worry, I don't think I'm going to do an absolute value on the test. We didn't really learn those. So that's kind of ridiculous to give you that. Let's see here. So minus x to the third power. Okay, so plus 6. So does this have any symmetry? It does have symmetry. Look at that, around the y-axis. Way-o. So we're going to say it's even. Way-o. Symmetric about the y-axis. Okay, so then we try the next one. You can just plug it into your calculator. Now you're going to have to use parentheses, else this isn't going to work. Plus 3x to the fourth power minus x, use parentheses, all divided by 2. And so we graph that, that's not symmetric at all, so that's neither. And then this last one, you can already tell because it's got an even power, but still graph it and see. So 2x to the fourth power minus x squared. Is it still recording? Okay, good. I was worried it hasn't been recording this whole time. I panicked. Okay, look at that graph. Does that look pretty symmetric? Yeah, that looks pretty symmetric. So that one is also right. So that one's also even. So we didn't even have an odd one on there. Okay, determine algebraically is the last part of our practice test. And I'm not sure, but this year it might or might not be on the test. So all you do is plug in a negative x, okay? You just plug in a negative x. And so if you get the same function back exactly with the same signs, then it's even. Let's see, negative x times negative x is a positive x squared. Negative times a negative is a positive 4x. And plus 3. And if you want to compare it to the original now, compare it to the original, just doing a video. So compare it to the original, and since the original is x squared minus 4x plus 3, and so it stayed the same, right? Those stayed the same. Thanks, guys. Those stayed the same. These signs stayed the same. Oh, but then one changed. So that was actually change. And since it's same, change, same, that's actually neither. It has to be exactly the same to be even, or all of the signs change to be odd. So if we plug in a negative there, we get a negative x 5 times. Thanks, guys. Yeah, so negative x to the 5th power 5 times. Negative negative is a positive x squared. Negative negative is a positive times a positive x squared times a negative x. So positive and a positive is a positive, x to the fourth power. But when you multiply it with a negative, we get a negative. X to the 1 and 4 is a fifth power. Let's bring that 3 in there too. So negative 3x to the fifth power. And then negative times a negative is a positive 4x. Right? So now we compare with the original, negative 3x to the fifth power plus 4x. And since we had a sign change, this changed, and this changed. And so if you have a negative and multiply it through the original, and then you get your new function, which we just did, the signs all changed, then it's an odd function. Odd function is right. So an even function would be this one. X squared minus 4x, maybe? No? Yeah? No? Just a second. So I think it would be x squared. Well, you can even just do x squared. So if you did like x to the fourth power minus x squared, for example, and you plug in a negative x and a negative x, then that would be negative x to the fourth power. This is just some random example I just made up in my head. Random example to explain even. So negative x to the fourth power and negative x squared. So negative is a positive is a positive, positive stays the same. Negative times negative is a positive, stays the same. And so when they both stay the same, when the signs both stay the same as the original, then it's an even. That's when it's an even function. Okay. All right. Thanks for studying hard. Watch it again. Rewind. Watch me again. Like, subscribe, and turn on notifications. Woo! Newble channel. Thanks for watching. Keep studying hard. You're gonna ace it. Bye for now.